Hi everyone, myself Satya, Department of Mathematics, SNS College of Technology, Coimbatore. In today's class, we are going to have the topic elastic membrane. Okay, this is one of the application in quadratic form to canonical form. Okay, so we are going to see a problem in this case. So elastic membrane, when x1, x2 plane boundary circles x1 square plus x2 square equal to 1, if it's stretched so that the point P, which is goes over into the point Q, which is nothing but y1 y2, which is given by y1 y2 as a column vector, and lambda x equal to ax equal to a is nothing but 5 3 3 5, and x is we already know, which is a column vector which contains x1 and x2. In the components, y1 equal to okay y1 equal to, just multiply these two matrices, we are going to get the form 5x1 plus 3x2. The second thing is 3x1 plus 5x2. Okay, now we need to find the principal direction, that is the direction of the position vector x of P, for which the direction of position vector y of Q is the same or exactly opposite. Either it should be same or exactly opposite. Okay, the next thing is, what shape does the boundary circle take the under their deformation? Okay, so we know that y equal to ax, which is the equation given in the problem. Okay, now a is nothing but the lambda x. Okay, so both are y, which means we can equate the right side term ax equal to lambda x. From that we are going to get a minus lambda into x equal to 0, which is the eigenvector formula. Okay, so the equation for 2 cross 2, which is lambda square minus d1 lambda plus d2 equal to 0. Find d1. Yes, we already know the matrix, right? So d1 is nothing but sum of the main diagonal, which is 10, and d2 is find the determinant of a, which is 16. For that we are going to get the equation which is of the form lambda square minus 10 lambda plus 16 equal to 0. Then we are going to get lambda as 2 and 8. The eigenvalues are 2 and 8. So we need to find the eigenvector. Okay, the eigenvector we need to add minus lambda in the diagonal. So we are going to get the matrix which is in the form 5 minus lambda 3, 3, 5 minus lambda x1 x2, then that should be equal to 0 0. Now replace lambda as 2, then we are going to get the equation which is of the form 3 3 3 3. That means all the elements in the matrix are equal. So that means we are going to get the equation as same. So we are going to get the equation which is in the form 3x1 plus 3x2 equal to 0. Just bring any one value to the right. So 3x1 equal to minus 3x2. Just cancel 3 and bring the value minus 1 to the left and 1 to the right. We need to write it in the ratio form. So we are going to get capital X1 as minus 1 1. That is the first eigenvector. Okay, the next thing is replace lambda as 8. So we are going to get the matrix which is in the form minus 3 3 3 minus 3. Okay, so we are going to get the equation of the form minus 3x1 plus 3x2 equal to 0. 3x1 minus 3x2 equal to 0. From that we can say both are equal, because if you multiply the first case by minus, we are going to get the second equation, which means we can say those two equations are same. Okay, if anything is common, just divide that value. So 3 is common, so you just leave that 3, write the remaining thing which is x1 minus x2 or minus x1 plus x2 equal to 0. Both are same. Okay, you bring that x2 to the right, so we are going to get the form x1 equal to x2. That means the eigenvector is what? 1 1. Okay, so this is as usual, we just wrote the characteristic equation, eigenvalue, eigenvector, which is step number 1. Next, for each and every step we need to find the direction. Okay, the eigenvalue. Okay, the first eigenvalue is 8. Okay, okay, for a lambda equal to 8, what should be the eigenvector? 1 1, right? So the formula is cos inverse of 1 by, you can take the first element square plus second element square, then find the root. That is the formula. So finally we are going to get cos inverse of 1 by root 2. The direction is what? Yes, we need to find the direction. So 1 by root 2, which is nothing but in which angle for cos, we are going to get the value as 1 by root 2, which is nothing but 45 degree, which is already we know, right? Using that concept we are writing. And the next thing is, yes, you can use lambda as 2. Okay, lambda as 2. What is the eigenvector? Yes, the eigenvector is minus 1 1. Okay, okay, why we are using here minus 1 and plus 1? You can check it in the last case also. Why we are using here 1? Okay, the numerator, which is nothing but the numerator term in the cos. Yes, the first value. We are taking one eigenvector, right? In that case, we'll have first element. So that element by square root of first element square plus second element square. And the second case is second element, cos inverse of second element by first element square plus second element square. Finally take the root. Okay, that is the formula. And in the second case, the root is what? Lambda equal to 2. The root is minus 1, 1. Okay, so cos inverse of, as usual, the first term is minus 1 by first element square, so minus 1 square plus second element 1 square. So finally we are going to get minus root 2, minus 1 by root 2. Okay, the next thing is cos inverse of 1 by, why we are putting here plus? Because in the eigenvector, the second element is plus. Okay, so 1 by square root of first element square plus second element square. Okay, only difference is the sign. The remaining is as usual, right? So the angle is how we are getting here minus 135 degree and how we are getting 45 degree. Yes, if it is positive value, directly we can have the value as the degree as 45 degree. If it is negative, you can subtract it from 180. Okay, so the angle is 135. In that way, I want to write those two angles. Okay, so now these eigenvectors, which is going to make 45 degree and 135 degree angles with the positive x1 direction. Okay, that we are getting in both cases, we are going to get 45 degree. We got 45 degree and 135 degree. So which is in the positive direction. Okay, so using polar coordinates, so polar coordinates is x equal to r cos theta and y equal to r sin theta. R is what? The eigenvalue. Okay, and second r is 2. 2 and 8 are the eigenvalues. Okay, from that find what is cos theta and here find what is sin theta. Now, the equation which is we already know cos square plus sin square is 1. We just replace all those terms. Finally, we are going to get the equation which is of the form x square by 8 square plus y square by 2 square equal to 1, which is the equation of ellipse. Okay, equation of ellipse we already know, which is x square by a square plus y square by b square equal to 1. Okay, the next thing is, yes, we need to make the direction. So here x is what? 64. Just find the square of the denominator. 8 square is 64. 2 square is 4. So approximately you can form the direction. Okay. 45 and 135. 45 which is going to cross in passing through the origin. Both case passing through the origin. Okay. If it is positive direction, okay, 45 degree means you can make it the principal direction which is passes through the origin. X direction has positive. X direction has negative, which is 135 degree. Okay, so this is the undeformed and deformed membrane. Okay, I think now you got an idea about elastic membrane. Okay, initially we started with characteristic equation, eigenvalue, eigenvector. Then each eigenvector, we need to find the angle. For that, we are going to use the formula cos inverse. If there are two values in the eigenvector, means we need to write two cases. Okay, so finally we are going to get the angles 45 and 135, okay, which is in the x direction. Then we need to make use of the polar coordinate, x as r cos theta, y as r sin theta. From that we are going to get the equation, okay, how it is deformed, okay, how it is formed. Okay, so here the matrix which is going to form the ellipse. So that is the thing, we are getting the conclusion from this problem. Thank you.